So the last presentation of the day is from Yaakov Stein, who is the CTO of RAD Data Communications in Tel Aviv. He also lectures at Tel Aviv University and actively participates in the IETF, where he co-chairs the TikTok working group, and he also participates in other standardization forums. He's authored numerous articles, patents, and standards, and a textbook, Digital Signal Processing and Computer Science Perspective. Before he joined RAD, he was Advanced Technology Manager for Comverse Information Systems, DSP and Neural Network Team Leader with EFRAT Future Technologies, and Professor of Artificial Intelligence and Computer Science at the Polytechnic University of New York, and Research Scientist with the Israel Ministry of Defense. Yaakov.
How do they make it appear over there?
Yes.
It's up. Okay. Hi, everyone. I want to talk a little bit today about a comparison between some of the stuff we've been doing for a long time in Ethernet and the new guy in the block, MPLS TP, that you've heard a lot about today. We're in a session on seamless MPLS, but I'm going to mention that I'm really not going to talk a lot about this seamless MPLS, and actually some of the terms I use, you hear them also in the seamless MPLS talks, but maybe they have a slightly different meaning, and therefore I'm going to talk a little bit more about the differences at the beginning. So anyway, what am I going to talk about? Right now, in the access network, if it's a packet-based one, the protocol being used is Ethernet. Of course, there's still access networks being based on SDH and TDM, but we're going to talk about the packet-based ones. And people are starting to talk about MPLS TP moving into that space, and we're doing a lot of work on TP in several organizations. And the question is, are we there? And is it even a good idea eventually to move over? So I'm going to start out with two short reviews, one on characteristics of access networks in general, how they differ from core networks, one about characteristics of Ethernet and MPLS TP, how they differ between the two different protocols, and that is a backdrop, will be input to the analysis I'm going to do. I'd like to just point out that the numbers in the analysis and some of these things are you can obviously quibble about. I'm not saying that these numbers are set in stone. I'll mention a few myself that maybe at this point I would change. But I think that the final numbers is what's going to be important to see. And we'll see how exactly TP compares to Ethernet right now. Okay, so when I say access network, what am I talking about? I'm talking about that blue network up there sitting between a core and some of these customers, and the customers I'm talking about are either residential customers who almost universally have IP as their interface, business customers who might have IP but generally have Ethernet, and the other important case are the cell sites, either the older ones, the 2G, 3G, or now the eNode Bs. And they might have Ethernet or IP or TDM, and they will always have timing requirements. The core itself might not be the final place you want to go to. It might be that your servers are sitting there, but you might be using the core to go out to internet or to data centers or to other sites of customers using VPNs and things of that sort. And in the middle, we have our access network, which is what we're going to be talking about. And basically, we're going to be talking about Q&Q Ethernet as compared to TP. Now, the reason those two protocols are the ones that people are looking at, well, on the customer side, as we said before, there's a lot of Ethernet. And people are moving that Ethernet and saying, why can't I take that basic Ethernet and move it into the access network? That would be the obvious thing for me. I have an Ethernet interface anyway. I have a UNI, which looks like an RJ45 or a fiber carrying Ethernet. So I'd like to simply extend that and forget about any other conversion. And the people come from the core say, well, what we have in the core generally is MPLS. Why should I convert that to anything? And that's what I always call the difference between the first mile and the last mile. The people starting the Ethernet, we'll call that the first mile. They want to extend out towards the core, while people starting in the core, we'll call that the last mile. So the question is, who's going to conquer the access network? is the Ethernet going to stay there, or it's going to be covered by people who are coming from the core and coming down? Now, I mentioned before that I'm not using the words in exactly the same way as the seamless MPLS people. I'm talking about an access network which has several different layers, perhaps in the last talk we just heard about making it simple. So we can have this last or first mile section going up to an access node, but then we can have an aggregation network, or what we now start calling the middle mile. And maybe some people just see MPLS going into the aggregation networking, leaving the last or first mile Ethernet. Some people see it going further. But I think the difference is more quantitative than qualitative. So I'm going to sort of mix it together, not exactly say where I want to stop and where I want to start with each technology, but compare them on a partially qualitative basis. So let's talk about the differences between the access and the core. Well, obviously, one major difference, and we've heard it several times today, is that access network have a lot more network elements than the core, while the core elements might be larger, more expensive, have higher bandwidth. But the very fact that you have lots and lots of network elements in the access means two things. Number one, you want to keep the price down, and number two, you want to keep them as zero touch as possible. On the other hand, the fact that the access has lower data rates means that you can't always assume you're going to get the quality of service because you're not over-provisioning, and therefore you'd probably need special mechanisms to be able to guarantee quality of service. And we'll see where those mechanisms are available. Another difference is the core is normally relatively richly connected as compared to access topologies, which are normally things like rings and trees, which means that in the core you can normally get away with fast reroute and things of that sort, while in the access you have to, in many cases, pre-prepare your way of doing protection switching. Run OAM to see that you have to trigger protection switching, things of that sort. Another thing I want to point out here, and unless we've heard about it here, there was a lot about it downstairs in the V6 sessions, is that core network elements are relatively well guarded, while the access network elements can be in someone's broom closet or basement. That is a big difference from the security point of view. And security is really, really important. I want to emphasize here that we can put a lot of effort into doing a protection switch in 50 milliseconds, but if someone can give us a denial of service attack which takes out the service for 2 days, then that 50 milliseconds is irrelevant. So we have to really look carefully at the security considerations, and we'll see that in a moment. Now let's talk about, really quickly, the difference between Ethernet and MPLS at a really basic fundamental protocol level. First of all, Ethernet starts from the ground up. There is a zero level, a physical layer Ethernet. You don't have to use it. You can layer Ethernet over other things, and of course you can put Ethernet over MPLS, a pseudo-wire. However, the important thing is that MPLS doesn't define as a server layer underneath, and you'll always have to define one, which of course could be Ethernet, and that's important. We'll look at it in a moment. Another important thing to say about Ethernet is that Ethernet frames are inherently self-describing. While MPLS early on we decided not to put a protocol identifier in, so when you get a MPLS packet, frequently you don't know what's inside, and if you want to do the kind of application awareness we've heard in several talks today, you might have to do relatively complex deep in-packet inspection, and if it's encrypted traffic, behavioral inspection and things of that sort, which can be complicated. Two other important things I want you to keep in mind are the next two. Number one, Ethernet frames contain real destination addresses, and they contain source addresses. While MPLS doesn't have a destination address, it has a proxy for that in the form of a locally meaningful label, and has no source identifier which can be authenticated. And this is very, very important from the point of view of security, as we'll get back to it in a moment. However, there are things in common. Both Ethernet and MPLS can take a lot of the same things from the top, like IP, and can sit on top of a lot of things from the bottom, like SDH and OTN. So there are things in common. Ethernet and MPLS right now define both fault and performance management, OEM, and automatic protection switching, etc. Ethernet, however, doesn't have a real routing protocol. Yeah, I know people talk about Trill using ISIS, and we've heard about using BGP to distribute hundreds of thousands of customer MACs and things of that sort, but let's leave that aside for a moment. We do have some layer 2 control protocols in Ethernet, but they're really not unified, while MPLS, of course, sits on top of an entire suite of IP protocols. Another difference, of course, is Ethernet cannot tolerate loops. Whether or not you're using a special protocol to find them or managing them, that's a problem, while MPLS does have a TTL field, so for a while can have a loop and get rid of it eventually. Ethernet and MPLS both define priority markings. S-tagged Ethernet can have drop eligibility, and a few other things here. Last one I think I should mention is that both have organizations which hold the pen, while there are other organizations wanting to move in on their space. That is, Ethernet is defined by the IEEE and MPLS by the IETF, but there are other organizations, including the ITU, who are working in the space, but in practice, there's someone who can actually make a final decision. Okay, that was the review. Now we're moving into the interesting part. My analysis is going to look, I'm going to look into Ethernet and MPLS TP from 10 points of view, 10 considerations. And I'm going to rank each of them for 3 things. Number 1, suitability. Number 2, coverage. And number 3, maturity. Now, I purposely take suitability at a lower importance, only 2 points. I want them to add the 10, so it'll be easy, right? But I say suitability, if something is not suitable, but you can get around it by doing a more complicated protocol, then maybe you lose some points from elegance. But it's not really that important. You can still make do. But coverage and maturity are important. So each of these things, I'm going to rank them from the point of view of suitability, only 2 points, but coverage, is the protocol there that solves the problem, for 4 points, and maturity, do we really have interoperable, certified ways of doing these, and are we sure that they're going to work, for another 4 points. Once again, you could change these things, and maybe I'll put up an application or something that you'll be able to fool around with them and try them out yourself. So let's start with fault management. It's received a lot of attention in the IETF and the ITU. Ethernet originally didn't have any OEM at all. It now has 2 different ones. That makes it fun. Having a unique source address means it's really easy in Ethernet to trace back. Unfortunately, Ethernet is not real client server, but we can cover up that. You know, it's not quite suitable, perhaps. We can cover it up by using the MEL in 1731. We have the 1731 features, which have pretty much everything you want. And importantly, all the interop events we've done over the last 5 or so years, and the certifications that we can get, and et cetera, all have worked out all the little details, and we can take 2 boxes from 2 different vendors, and it works. MPLS didn't really have a full-featured OEM. It had, BFD and things of that we could use. But as we all know, the projects going on in the standardization organizations really sat on that space and developed solutions. So what do we have? Suitability, as I said before, Ethernet has a source address, therefore is highly suited. MPLS doesn't have an address, so it requires some work, so I'm taking off 1 point, but don't worry, it's only suitability. Coverage, MPLS, I didn't mention before, is missing 1 feature. I took off a point for it because it's important in the access network, and that is for endpoints. If you really want to get down to the end, there's something called dying gasp, which is really, really important in certain cases, so I took off 1 point for that. Maturity, well, as I said before, 1731 and the IEEE version, at the beginning didn't interop, but we did so much testing, and we have, if you pay them the money, you can certify your box and go through abstract test suites and all that. So Ethernet gets full points on that one, while the TP gets less. Right here, Ethernet wins out. Performance management, the ITU version of 1731, unlike the IEEE version, has performance management in it. 1731 is also the base for commissioning procedures, the Y1564, which is relatively new. And interoperability has been demonstrated in interop events and things of that sort. TP does have now 2 RFCs and actually has some nice features now that we're missing perhaps, like the dual timestamping, use the NTP format versus the 1588 format, and et cetera. And all the lessons that were learned are put in here, but implementations perhaps are still lacking and we have to interop them. So suitability, bottom line, tie. Coverage, tie, by design, everything we put into 1731 was reported back to the IETF. People listened, built it all. But maturity, well, big difference. The Ethernet stuff, as I said before, has been tried over and over again, and you can just drop in equipment, it works. The TP, it's going to take a few years. Automatic protection switching, I'll do this one quickly. I'm watching my time here. Basically, we need linear protection, ring protection. Ethernet is not suitable for rings in general. As I said before, there's a problem with rings in Ethernet. We've gotten around that in 2 different ways. However, all of the mechanisms that use open loop, like 8032, do it at a price. You lose a lot of the quality of service mechanisms once you do that. MPLS in the core has fast reroute, but that's, as I said before, needs the rich interconnection. When you don't have rich interconnectivity, you have to do something else. There is an RFC on linear protection. There are proposals for ring protection, but there's not an RFC yet, so we lose a point there. So right now, bottom line suitability, MPLS takes it because there's a problem with rings for Ethernet. Coverage, Ethernet edges out because there's not an RFC yet for the ring protection. Maturity, once again, TP loses out because we haven't had full-size interop events and certification programs. QoS. 2 kinds of QoS. I'm not going to talk about the hard QoS, the TE stuff, because, well, it exists in MPLS, but that's TE, not the TP version. There was, of course, the Ethernet version, the PBT stuff, but let's not talk about that, right? Ethernet has the soft version, traffic conditioning, in other words, token bucket algorithms, standardized, tested. We know how to measure it. That's right now not in MPLS.